recording. So, intermediate algebra, Monday, October 12th. We're recording. Okay, let's share the screen so I'm not. So what I did, created a homework. The homework, the review homework. Yeah. Let's see, review homework. So if this is Alex.
Is it going to be like last time where it was similar?
Yeah, similar, but they're a little more. Okay. More than the test. So here is homework chapter 10, right? It's due the 17th. The chapter 10 objective is due the 16th. Friday. And then the test itself is due on the 17th, Saturday. I figure out, let's not wait till the last moment. It's supposed to be due to Wednesday, but I extended it. Yeah, the thing is I didn't know who is coming, who is not. Are we going to test in class or not? That's why I put it on here in case we're doing it in class. But since we're doing it online, oh wait, you're doing it at home, right? Test chapter 10, wherever you want. So that's why I extended it, because no point to leave you 1, 2, 3, 4 days without doing nothing. You can.
Oh, there's plenty to do.
No, but you can push. You can push. Okay, so now. Let's see. I think we should start backwards. Let's start with the hardest problems. Well, it's good. Let's start from the back.
I think this has been the hardest chapter.
Yeah, it is the hardest. And again, this is one version of it. When you do it at home, it is going to give you other numbers, but the same type of questions for the homework. So. The homework. Because we're doing one version of it, I just clicked one, but it gives you others. So we're starting backwards. In case he wasn't here, so let's see if he learned anything when he was not here. So we did like the complex numbers last time, Jason. Right? Did you practice anything about them? Oh, good. So here, let's do 44. Simplify this number as much as possible. So,
are we getting a paper?
No. Do you want a paper?
Oh, no.
No, you don't need the paper. But if you want, I can print you one. Here, problem 44. Right, so how do you do that? If you want a paper, do you want paper? No, it's good. You don't need, because the answers are different, I guess. Yeah, so we need to. You're taking notes. And what am I doing? I am just checking on something. Is it correct? Oh, it's processing. Yeah.
Jason, you didn't post on the video. Now
because he didn't watch it.
One of us gets extra credit.
You see, because you don't watch it. I know nobody's watching it. Yeah. But the good thing, Mariana, you didn't. Maybe I should give extra credit because you didn't tell him. Okay. So I need to.
I can't even remember.
Yeah, also look at your notes and see what you can do. Jason, do you know what to do?
21. Oh.
21. Forever 21.
Yeah, that's my favorite store.
Yeah. Nothing fits me there. I don't know. In this store. Yeah, I mean, I didn't really look, but everything seems like small size.
No, you gotta look.
Oh.
I'm not tiny either, so
well.
There's. I think you can find some stuff.
Yeah. Better go to JCPenney or something. Okay, so now what do we do? Yeah. Here you go, like that. And then what do you do? Now what? Yeah, your goal. What is your goal? You want to get to the I squared, which equals -1. This is how. So you're going to divide the 20 by 2 and do like 10, right? So you want to take advantage of the fact that I squared is -1. So then this will turn into -1, because it's what I squared is. Then -1 to the power of 10 is what, Mariana?
10? No, 1.
This one, okay. It's 1 times I, and 1 times I is I. So this is the answer. So again, if it's an odd number, you get one of the i's out, you know, one I is out. And split. If it was an even number, you just start with the splitting. Split, don't need them. Okay, you see how easy we did one problem. What am I doing? Next one. Okay, I'm going
43.
43.
44 problems in the test?
No, I just put more.
You said there's more?
No, I put more here
Oh.
to practice more. So trick you because you can. I'll make it to learn more of them, but then I'll give you only few. You see? I could have just given the same amount, but I'm like, no, you need to learn more. Okay.
I already got a catch-up.
Well, we all do. Oops. Okay, so now what do we do? Oh, shouldn't have put this. What do we do? Jason, do you know? Yes, so how do we do that? That's corrected by the conjugate. Okay. Oopsie, I don't know how this line came up. Sometimes they, okay, so keep going. Let's see if you can do it. So do it and see if you can get the answer. In the denominator is this difference of square formulas, which is the first thing squared, I'll just write it, minus the second thing squared, which is 5i squared. But since if you have done a lot of those, I'm not going to do the top yet. If you have done a lot of those, you know that the I squared will turn the denominator into a sum. So it's going to be 4 plus 25 technically, right? Because if you have imaginary numbers, when you do the difference of squares or when you multiply the conjugate, you just get the real part squared plus the imaginary part squared. Okay, so now let's do the top. Oh, yeah. Okay. Okay. So this is 29. So top is minus 8 minus 20 plus 8 plus 20i squared. I'm distributing, multiplying the numerator. Okay, add the like terms and we get, and also know that this is minus 1, the last thing. I don't know how. So this
it'll just turn into minus 20,
yeah,
right?
minus 20. So minus 28 total. So the whole thing would be, I'll just write the minus 28 since we talked about it. Minus 28, and then we have minus 12i over 29. Yeah.
Where do you get the 28?
Because the minus 20 and the minus 8. See, you add them, they're like terms.
Oh, yeah. I thought you were adding the i's.
I did the i's. They're minus 20 and plus 8.
Yeah, but I thought you were doing.
Oh, yeah. Well, so usually, okay, here, and see, this is what is the important part right here. It says, write your answer as a complex number in standard form. So the standard form was A plus BI, right? This is the standard form. This is what, so you need to write this like that. So what you're going to do, you're going to split it in the real part and imaginary part. Right? So this would be the correct way to write the answer. Moving on. 42. Oh, this is so easy. Come on, do it. 42. Multiply those two thingies and tell me what the result would be. Oops. So I think because I know Hannah is watching, He's watching us. Maybe no. She didn't do either what we said to do. What, I don't even remember what we, why would she be embarrassed?
No.
She would like extra credit. She didn't watch it. It's not, which is not a problem because Alex explains. If you can handle it with just Alex, fine. But if you cannot,
That is why I'm here.
okay. Is this the right answer, Jason? Okay. How about you, Mariana?
6 minus 79?
Yeah. Okay. And it is in standard form because I have this is A and this is B. Check, check. Oh, next one is too easy. Okay, you know how to do it. Moving on. Right. What you need to do when you won't do it, I'll just remind you that what you need to do, you need to distribute this minus. You see the minus?
Mhm.
So then this will be plus 4, and then when you add them, you get whatever you get, right? Right. Okay. So you just add the like terms. You can do it. Okay. Next one. Okay, let's try this. Simplify the expression as much as possible and leave no negative numbers under the radicals. And no radicals in the denominator. So they're like, oh, but there is no problem with that, really. So first you need to do the i's. Extract the I thinking. I always think about the Bible when I say extract the eyes. You know how those things when they poked everybody's eye, let's say, which king was that? Nebuchadnezzar, or got the Israelites in Babylon and poked. I think he blinded them all. It wasn't. There was another guy who just blinded one eye. Because when I say like the eyes, remove the eyes, do the eyes. It's just, I always think about the Bible. It's the Bible. At least I'm thinking in biblical terms. Okay. So the first thing to do, you're getting the eye. I know. 42, and then so get the eyes out. But the eyes would cancel on top of that. It's okay. But so now you can combine the 42 and 6, divide them. You can make it so the I think cancel. So 42 over 6 turn out to be 7. So the whole thing is square root of 7. Is it? Fair? Problem 40. 40. What is this? Yeah, square root of 7. I mean, this one is just turned out to be nice like that. What you do when you see negative square root, you make it into I times whatever the square root is. Radical. Doesn't need to be square. And then the same thing with the denominator. This one happened that those canceled. And also it happened that 42 divides by 6. So if you combine them, you can just get a number without denominator. Just happened like that. Okay. Let's do the next one. What would the next one be? Okay. So we need to get the I. Write in another I. So, okay, this is 2 times 5, and this is 2 times 3. I'm just see if I can get something out. And I can get the 2. There are 2 2's. Yeah. So this would come out as 1, 2, kind of. Whatever, it comes out like 2. So I'm going to leave the I squared so we can finish this.
So does that go to negative?
So this 15, yeah, it's going to be negative. So the whole thing would be negative 2 square root of 15, right? Because 3 times 5 is 15. So that's it. This one is super easy. This is not hard. The imaginary numbers, the complex numbers are not hard. But, oh, now this is super easy. Okay, let's do it. Write this in terms of I. But simplify. See how much you can simplify. So 96, see what we can do with 96. I don't know, do the 3 thingy. I can divide by 2 for sure. This is 48, right? 96, and then this is 6 times 8, or 3 times 16. 3 times 16 sounds better, it doesn't really matter. And this is 2 times 8, which is 2 times 2. Oh, 2 times 4. Oh. So the whole 96 equals to, would equal 1, 2, 3, 4, 5. 2 to the power of 5 times 3, right? So let's put this under the radical and see. Okay, so we have the I in front. This is a square root, so I'll just make this into 2 to the power of 4 times 2 times 3, which is 6. All right. I left 1 at 5. So then this is square root, so this technically is 16. So what comes out from 16? 4, yeah. Or because this is 4 divided by 2, 2, or 2 squared, so 4 is going to come out. Right, the answer is going to be 4i square root of 6. 39. Yeah. Okay. This was the easy part. Well done. Or not?
Yeah.
Okay. So then let's see. Okay, now solve the question. See this one? Okay. We need a lot of space for this one. See, we're going to 38. So I'm going to put it right here. Okay, move this here. Press something. Where were we? Okay. I just press another tab right here. Okay. So let's start. You need to solve this problem right here with red. See this one? What do we do? What do we do? That's right. So see, okay, how about I'll do this part. Okay, we start here. So I'll keep this radical on this side. Equals 1 plus this radical, the other one. You need to isolate the radical. Okay, now get going. It's a long one, you know. Now you square both sides. And here you FOIL them, unless you know the formula. On the right, multiplied by itself. Okay, so I'll do it and you do it. That's good if you can do it on your own. Yeah, so you're going to still have a radical left. Wow, this is a good one. Here you go. It's one of the longest possible so far. Right, because not only, so I squared both sides. The result here is what will happen if you distribute this, if you multiply it by itself. See this? I got it by multiplying 1. I mean, I know the formula. If you don't know the formula, you have to multiply this by itself. Right? So multiply it by itself and see if you get what I got. Start. Yeah, give you green arrows. 1 times 1, blah, blah, blah. This time this and this time that. If you're going to get what I got. Monday. So your goal is to obtain this red expression I got right above the blue one by distributing. Thank you that I need to take gum or something.
To wake you up?
It's Monday and I had like almost 5-day weekend.
What?
Well, those who didn't have school Wednesday, Thursday, and Friday, they had some conferences. So I didn't have to go super early. And I didn't even come Thursday and Friday. So I still work from home. Okay, Jason, did you get the red thing? I mean, you should get what right here. You should get this. You got it? No. Now we need to see that I said it's super long. Now we need to distribute. See this thing? You need to multiply this by itself. Mariana, did you get the red thing first?
No.
Ah.
I'm confused on those.
Yeah, well,
Just keep going.
no. You have to multiply them by themselves, right? So here, 1 times 1 is 1. 1 times square root is just square root. Then square root times 1 is square root, right? That is the same thing, right? I'm doing this one now. And then the square root times the sum itself is going to be square root squared, right? This is what you're getting. I didn't just write the insides. So when you add them, these are the same, like terms. So I'm going to have 1 plus 2 times the square root. Now I can write the inside. Plus, you see I got this. Oh, I made mistake. Good. Plus, you see it's not squared because the whole square root was squared. So this means the square root falls. I was excited we got something super hard, but it wasn't. Okay. So this is what you get. 2x plus 8, right? And just do the thing, good thing we saw it, otherwise we would have put a lot of effort. Okay, so then we're right here. So actually don't even need this, huh? And now we are going to add the like terms. You see the 1 and the 8? You can just add them. So see, it's going to be 4x plus 17 equals the 1 and the 8 are like terms. So I'm going to add them. So it's going to be 9 plus 2 square root of 2x plus 8 plus 2x. The order doesn't really matter. This is where we are. So now, what's the next step? Yeah, but you cannot just square them like the way they are. This was the first part. No, this is the first part. Isolate. Yeah, you can do the like terms, but let's do the like terms. Okay, good idea. Let's do the like terms, but then you need to isolate the radical. Okay, this is your go-to again. But let's just add the like terms. Okay, 4 minus 2. I guess isolate the radical. Let's isolate it on the right. Leave the radical on the right. Okay, here. So this is part 2, the second part. The second part. Part 2. So we're going to isolate the radical. Do pink. So I'll leave this radical here, right? I want it to be like this, equals 2 square root of 2x plus 8. This one stays the way that it is. I'm minusing the 9 to the other side, right? So it's going to be 17 minus 9 is 8, right? So I'm having the 8. And then 4x, and then I have the 2x. So minusing the 2x is going to be 2x, right? So your goal is to isolate the radical. We did it once, we isolated it. Now we're isolating it again as purple. There is a good thing right here. If you don't see it, it's okay, but I saw it, which is, right, minus 9 is 8. You see they both divide by 2. This one, and this one. So it will be beneficial to divide by 2 right now. So when you do this, you're going to get x plus 4 equals this radical, a little better. Not too much, but still. Okay. So now let's square both sides again. Okay, I'll just write it by, I multiplied twice. So this means I have x plus 4, x plus 4, right, multiplied by itself, equals, the radical falls out, so 2x plus 8. All right, Mariana? Okay, so now multiply this by itself on the left. So what you're going to get after you add the like terms, x squared plus 8x plus 16 equals 2x plus 8. So now, this is quadratic, right? The highest exponent is 2, see x squared. So then what you need, how do you solve quadratic equations? What do you know how to do? Jason, what do you
Combine it like that?
You combine them and what? Set them equal to 0, right? Moving them to the other side. Let's get orange. I don't like orange, but we have x squared. 8 minus 2 is 6, so plus 6x. 60 minus 8 is 8, plus 8 equals 0. Oh, we can factor this, right? Can we? Which two numbers multiply to give you 8 and added together give you 6? Yes. Thank you, Jesus. Here. Plus. Right. So the solutions are, what are the solutions? The zeros. Because you're supposed to solve it, right? It says solve. So x minus x equals minus 4 and x equals minus 2. However, you're not done yet. Why? What do we check? We need to check because these are the weird ones. I was just going to be yeah, but oh, there is one I think forgot one. Okay, so take the number. Okay. So we're taking this orange 4 minus 4 and we're going to put it right here. I. Let's see what we get. So it's going to be negative 16 plus 17, the square root, and the other one would be negative 8 plus 8. Right? Does this equal 1 is the question mark. Right, Maria? Question mark, does this equal 1? And let's see. 17, now minus 16 and 17 is 1. So this is square root of 1, which is 1. So here we have 1 minus 0 equals 1. Yeah, the first one checks. Okay. So the first one is a solution. So this one is. Let's check the minus 2. Same thing. Come on. Okay. So minus 2. Minus 2 and minus 2. So does it check? So it's minus 8 plus 17. And this is minus 4 plus 8. Okay. What is, this is 9, right? Square root of 9 minus square root of 4. So square root of 9 is 3, right? Square root of, oh wow, this one too. Oh, they both work. Okay, then they both are solutions. Oops. Check. This one is a long one. I'll give you a secret because you're not, nobody's going to watch the video, but I did not put one of those on the test.
Oh my God.
Because I was lazy from last time, it wasn't there, so I didn't put it. Okay.
Oh my goodness. Jesus loves us.
But you still, you know.
Yeah, it's still good to know it.
Because there is one with 1. No, there is. I didn't put one with 2. All right. There is one. Okay, so this was that. Done. Another one. Let's see the next. So this was. Okay, 37. Let's do 37. This one has a. It's okay. This has one radical. Oh man, actually. Yeah, it's one radical. So what we need to do? We are going to, we don't need it so big because we get like fuzzy square roots. Well, what do you need to do? You have radical. So what's the first step to do? It is isolated already. So then what's the next step after you isolate the radical? Jason, how do we get rid of the radical? Square both sides, square both sides. Now I lost my drawing. Why? What happened? What did I do? I did something. Oh, here is my drawing. Yeah. So square both sides, right? All of a sudden I had this urge. I want to go to a movie theater and sit down and watch a movie.
You need to get a projector.
Oh, I can watch. I don't need to. I can just watch it at home and on the TV, but it's not the point. Okay, so when you square the radical, what happens? It falls. The radical falls. So you don't have radical anymore. Equals w squared. Okay, now what? Boy, now you should be able to do it. It is quadratic, right? So combine the like terms and make it equal to 0. Okay. So all those, they need to end up equal to 0 if they have a w squared. Can we or can we not? What do you think, Jason? I think we can. Yeah. What is it? That's right. Right? Because negative 2 times negative 6 is 12, and when you add them together, oh, this is so nice. So this equals, if you set this to 0 and this to 0, w is 2 and w is 6. But now we need to check. Don't forget to check. Just those square root ones, check them. Check. Well, the numbers. Let's see what happens. 2. And minus 8, 4. The first one checks. Right? How about the second one? Put 6 there and see what happens if we put 6. 72 minus 48 plus 12. 8. 7. Or maybe what is 48 minus 12? 36? Oh yeah, 6. No, yeah, oh, it works. I forgot to put 6 here. I think it comes out to square root of 36, which is 6. So they both check. Huh, look at that. Okay. See, this is how this was solving radical equations. The variable was under the radical. So just realizing that it is what it is. This is our last review actually, because the test is on Wednesday. Right? So we're doing it at home. So better speed up. Got this. Okay. Another one. We're doing it quickly. Okay. Stop.
Square.
Because these are hard. Square. Good job, Mariano. See, square process. So the second, the right hand side, when you square, just multiply it by itself, since I know you like to do that. So then this would be minus w plus 27, right? Equals. So move them on one side. So w squared, because it's quadratic, you know, the first exponent is 2, so you need to set it equal to 0. What is this? 9, 27, 18. Is it 18? What is it? 27 minus 9? Okay. Oh, does this factor? 3 times 3 times 6 doesn't work, or 2 times 9. 2 times 9. 2 times 9. Right? If you do plus 9 and negative 2, right? 2 times 9 is 18, and then when you add them together, 7. Okay, W is minus 9, W is 2. I'm leaving the check-in to you. You check, you know how to check, right? Check. Okay, because I realize we have more practice. The next one is the same, square both sides, blah, blah. Number 34, square both sides. And there are no squares anymore, so then you're good. Don't even need to check. This one, 33, you need to isolate the radical first, right? By minusing the 2, and then the same thing, square both sides. Okay, got it. 32. Let's do 32. Rationalize the denominator. So after we're done today, I don't know. Should I remove? I mean, there are 44 problems. Should I remove some of them? I'll leave them all for the homework practice.
I think we should do them for the practice.
I'll leave them for the homework. Oh, I'll leave them. Okay. So rationalize. Okay. So what do we do? How do we rationalize this denominator? You have to get rid of the radical, right? To go. So the conjugate.
Oh, those conjugates.
Wow. It almost sounds like a bad word for a brother or a sister, you know, like for siblings. You're a conjugate. You know, if you're mad that you're a twin sister or something, tell them you're a conjugate. Jason, do you have twin brothers or sisters? No. I mean, I know the answer. And I don't know how they do it, but I think it's easy. I don't know, some don't. Okay, let's go. So multiply. The denominator, you know what's going to happen, but I'll write it. Yeah, you square it. So it's going to be 3 square root of y squared. Right? Minus 16, the square thing. On top, we just distribute the 3, negative 3 to this thing. So the top would be negative 9 square root of y, negative 12. Top. This is top. The denominator would be, now we do the square to the 3 and the radical. So it's going to be 9y minus 16. And the top looks like that, and you just abandon it like that. Do they divide 9, 3? No. Okay, good. That's it. That's it. As long as there is no radical in the denominator, you got it.
But there can be a radical in the numerator?
Yeah, the numerator doesn't matter. Could have everything there. The denominator was the goal. This is what means to rationalize the denominator, it says.
Oh, okay.
Make it rational. Get rid of the irrational part. Oops. Yeah. So moving on. Yeah. So another one of those. I'll show you what to do. You just multiply. So it's going to be 5 minus 2 square root of 2, right? Okay. Conjugate. So let's do the next one. Yeah, the evil twin. Okay. So then this one, again, conjugate, but not really conjugate. This one, the conjugates are when you have plus and minus. There is no plus and minus. So this one just multiply by 2z. Right? And this will take care of just going to be 2z in the denominator. Right? You multiply it by itself. Technically, you squared it, and the square removed the radical. And on top, you have square root of 10z. Because the 5 and the 2 multiply.
And that's it?
That's it.
Oh.
See, easy peasy. Okay, so moving next one. Simplify. So, simplify the 72. What the only thing you can simplify is the radical. Now we're getting into doing the radicals, simplifying them. So 72 is 9 times 8, right? Hey, this almost, and 8 is 2 times 4. You're looking to make them into squares, perfect squares. So essentially, square root of 72 would be square root of 9 times 4 times 2, right? Because 9 times 8 was 72, right? And so here's the 9. And then 8 was 2 times 4. So I just turn them around a little bit, right? So square root of 9 is 3, square root of 4 is 2. It's left, right? Okay, because
No, I understand it.
you guys, this is square root of 9, square root of 4, and square root of 2. You're kind of splitting them. I split them right there. Split them, and we get, so going back to our problem, so this would be 6 square root of 2 minus 4 over 8. You're like me. Okay, what you can do, since you're here, you look at 6, 4, and 8, they're both even numbers. So you can actually divide them both by 2. 2, 4, 3. So this is the simplest you can get. 3 square root of 2 minus 2 over 4. I know. I just realized we need to hurry up. That's why I started doing them. Otherwise, I would make it to them. Because I want to get, I want to get them all. Next one.
It's a lot of.
You can do this. I don't need to do it for you. No, multiply, right? Distribute. That's it. Let's do this one. Take what you can take out. Your goal is to make them the same if you can under the radical. Might not. It's not a big deal. 75. 75 is actually 3 times 25. You need to know the secret code. 48 is 3 times 16. Another secret code. All right. So then square root of 75, that would be 5 square root of 3, and square root of 48 would be 4 square root of 3, which is good. They both have square root of 3. This is my the prequel, like the work you do before you do the actual thing. So then 75 so comes out as 5. Yeah, but then what happened to the W? How many W's you can take out? There are 5. How many groups of 2 do you have in the 5? 2 groups of 2, right? So we're going to get W squared out, and then you have the 3. Oh, it did that. Oh, you're right. You're right. That's right. Thank you. Just one W because. Oh no, it's a square root. Wait, that's 2. Oh, I forgot the W. I was like, oh, that's right. Fine. The other one is 5. It was 5 in a W, but now we need to multiply 4, right? Because this is from the 48, and another W. I'm not getting too much here. We use different color codes will be okay. And then the square root of 3 in a W. Oh boy. E. So okay. 5W squared. Yeah. Square root of 3W plus 20W squared. Square root of 3W, right? Oh, well, you think you're done? But you're not. This is W, not X. And what they want you to do here is not really so important, but since they're the same, you make them the same. And they want you to like combine the like terms. The way to combine like terms here is, oh, they're exactly the same. Oh, look, they're like terms. So it's 5 and 20. You need to just add the 5 and 20. See, they're the same. Yeah. Yeah. Let's see. This problem number 27. Check. Make sure we got it right. 27. Yeah, it was easy. Because otherwise, if they're different, if this was cube, for example, what you had to do, you had to factor out this thingy, 3w, and then leave the inside. And you had to probably factor another w, but in general, we can factor out the common factor and then leave the inside. But hopefully, you don't need to do that. Need to check, make sure you got good ones. Okay. You can do this, you can do it. Okay, so what you need to do, the first one is 3 times 25, the other one is 3 times 9. So square root of 3, y would stay, and then you have numbers, and you can do it. Okay. You can do it. These ones are numbers. Oh, let's just do this one quickly. So 27 is 3 times 9. This is 3 times 4. And this is just 3, right? Do you see it? Mm-hmm. So then the 9 comes out and the 4 comes out. So the whole thing would be 2 times, the 9 comes out as 3, right? And the next one would be the 2 comes out from the 4, so 3. And then the last one, nothing comes out, right? So it's going to be 6 minus 2 plus 11, whatever this is. So it's 4 and 11, so 15. 15 square root of 3. Yeah. Jeez. Okay, next one. Next one. Okay, this one, what you can do, looking at them, you're like, 5 and 45, they divide. So what you're going to do actually, you're going to combine them. Just because you saw that 45 divides by 5, which is what? 9, right? 1, if you divide them both by 5, you're going to get 1 over 9. And then, now you can split it again for fun. Right? So it's going to be 1 over 3. Or you can just do it without splitting them, but if you need steps, you just split them. Right. This one is one of these ones. Okay, I erased it. Right. So, well, let's see. I'm looking for one. No, let's attack this 19. I'm looking for the one a little more complicated. So what do you need to do? They say, write this expression in simplified radical form. So they want it as a radical at the end. So let's see how many groups. So you see this is 4. So let's see what comes out. 32. Can you make it the power of 4 of something? 32 is 4 times 8. But we don't like it yet. I want it to be, okay, here, 32. I want to see how many groups of 4 are there. So this is actually 2 times 16, which is 4 times 4, which is 2. So it's 2 to the power of 5, technically, 32, right? If you do the 3. So then I got it that I have 4. And this is 2 to the power of 5, and the rest is what it is. Right? So now let's see how many groups are there. We can take out. So the first one we have 5 twos, right? I can take one group of 4. Right, Mariana? So one group of 4 just give me 1 2, right? But 1 2 stays because I have 1 extra. There are 4 fit into 5, but you have 1 extra. So the 2 stays. Let's look at 18. How many groups of 4 you can fit into 18? 4, like 16, so it make it 4. So I'm taking, okay, let's get different color. So I'm taking y to the 4th right here. Wait, is it 4? Yeah. Because, I have 4 groups of 4 is 16, and I have 2 left. You see, from the 18, there'll be 2 left right here. And then 8. Hey, this is good. How many groups of 4 fit into 8? 2, so nothing left. So I need to squish it somewhere. So it's going to be z squared. So it's going to be 2y to the 4th z squared, and then it's 4th root of 2y squared. See the 4th root? So when you do your Alex, make sure you put the 4th root there, because otherwise they'll say you're wrong. Oh, it's a big 4. Don't forget. So that is to look at groups of how many? Okay. No, it's like it's okay. And if you cannot, if you like on the test, you totally fail it. It's okay. It's just one chapter. Out of 4. So the other ones are different. Okay. I mean, it's possible, you know. You don't have to, but okay. 375 by 3 is like groups of 3. Divide this by 20. Yeah, 25 times what? Well, I think it's 625. No, 25 times 25. Wait, 25 times 5 is 125. 675. Let's divide by 25 first, I guess. I mean, let's see. Let's divide by 25. 370 divided by 25 is 15. So this is 1525. So we can go after the 5 groups of 5 then, because 25 won't work. So this is 3 times 5 times 5 times 5. Here we have one group of 3 5s. All right. So then 1 5 would come out from this group. So 5 cube root of 3 will be the answer. Okay. Yeah. Easy. Okay, the same idea here. Take groups. Take groups. Same idea. Groups. Yeah. Groups, more groups, and more groups there. Figure it out. It's 2 times 25. So it's going to be 5 square root of 2. Now simplify. Let's do this. Okay. Simplify. This is actually super easy. What you need to do. What do you do with exponents when they're like a, x, y? You multiply them, right? So the same thing here. This is 2 over 1. You can write this as, so it's going to be y. 2 over 1 times 7 over 6, right? Because the 2 is times 7 over 6. I just put the 1 so you can see the fractions. So when you do that, then you can cancel the 2 and the 6. So it's going to be y 7 over 3. Let's read the instructions. Simplify. Okay, write your answer without parentheses. So that's it. This is all they said to do. So we did it. Let me see 13. 13. Again, read the instructions and those to see what do they want you to do. Yeah, that's it. This is the answer. Because sometimes say use a radical, don't use a radical, whatever. Just do what they say. Come on, this one. One thing they say, right? Using positive exponent only. So make sure to do that. So what do you do with the exponents when they're divided? Subtract them. So it's going to be x to the 1/2 minus 2 over 3. Right? So they do common denominator here. 3 and 2. 3 minus 4. It also is negative. Right. 3 minus 4 negative 1 over 6. But they say, write your answer using only positive exponent. So how can you make this a positive exponent? That's correct. If you want exponent to be a positive and it's negative, move it down. Or if it's down, move it up. Just move it one layer. Did they say anything about radicals? No. So we can actually do it like 1 over x to the 1/6. They didn't say anything about that. Or we can do it 1 over 6th root, but I don't think they, let's see, 12. I don't think this was the goal. 12. Yeah, you leave it like this. Otherwise, they'll say problem. Okay, let's see what's left here. Anything exciting? What do I need to do? Okay, this one says write your answer without exponents. So how we do that?
You put the 2 square root of 4, isn't it?
Yeah, it is square root of 4. So you're right, but it's a negative. So what you need to do first, you don't know what to do with the negative, so you need to make it positive. So first you make it like 1 over 4 to the 3 over 2. And then you do what you said you wanted to. Because otherwise negative exponent doesn't make sense. So it's going to be 1 over, so you have square root, as you said, square root, you don't need to write the 2, but okay, 4 to the power of 3. Now let's simplify this. You have 2 and then a group of 3 fours, so right? So one group of 2 fours can come out. So a 4 would come out, and you have another 4 here, which is weird. Wait, didn't you write? Wait, no, yeah, it is one group of 4, but this square root of 4 is 2, right? So the whole thing is 1 over 8. Right. Oh, let's see. Okay, so because it was, where is this 7? This is 2.
Oh.
4 times 2. Because square root of 4 is 2. The idea was, the exponent was actually smaller. I mean, this was smaller than the 3. So obviously something can come out. And you had, this is 4 squared times 4. So we got the 4 squared as 4, but then we had another 4, which we know what it is. Like that. How about this one? Next one, the 16. Okay, let's do this. So first 1 over that, right? Oh my goodness, you're serious. Oh wait, we can do something. Oh, let's do the shortcut.
Oh, yeah,
Shortcut. What was the shortcut? When you have a negative exponent in a fraction, what was the shortcut to make it positive? It's called it's a shortcut. So we're going to do a shortcut. With this, if you flip the fraction, it's going to be a positive. Flip the fraction.
I was thinking something. What is it called? What do they call that? When you flip the sign?
KFC? No, not the sign. Which sign?
Not the sign. The fraction.
Yeah.
There's a name for it.
Oh, reciprocal.
Yeah.
Oh, you can do the reciprocal. Yeah. Okay, reciprocal. So what happened? The only thing which happened, I left the 1 just to see. So we flipped the fraction, and the only thing which happened, the minus disappeared of the 3 over 4, right? So then this is just 16 3 over 4. So write the 4th root thingy. They want without exponent, right? So they want you to have radicals. So right here, radical 4. This is 16 to the 3. Unfortunately, you can simplify this because it's 16. Oh, so 16 is 2 to the power of 4, right? You can figure out later. So when you do this, so essentially you're having 4th root of, instead of 16, I'm going to write 2 to the power of 4, and the whole thing was cubed, right? The cube, nothing happened to the cube, right? I just substituted 16 with 2 to the 4th, right? So now we have 4th root of 2 to the power of 12. Or you can see how many groups already you have, but how many groups of 4 fit into 12? 3. So the whole thing is 2 to the power of 3. No, this is like, you could see it here though. See, let me get green. You see how we have 4 and 3? You can just flip those, put the 4 outside, this inside, and you have 4 groups of 3. Okay, let's see. So these are tricks with numbers. Like this one same, this one same. You need to figure out what it is. Let's do this one. Find the domain. What is the domain of this number 7? And we're almost done. What's the domain? I guess we don't want to do the whole thing. The domain is whatever this is needs to be greater or equal to 0, the green, right? The radicand. This is a domain. Domain is like what are the values of x for which this expression makes sense, and it does not make sense when you have negative numbers under the radical, right? So I need to make sure that the domain will be any values of x for which the green thing, the radicand, is positive, right? So I need to solve minus x greater or equal than 0. So now solve this for x. How do you solve this for x? The easy way or the hard way? The easy way is move the x on the other side. Plus x, yeah. No, it did already because the x is there. Yeah, it flipped it. It's already flipped. You don't need to do it the extra flipping. You just, because, you know, I did it so x is on the other side of the sign already. So I have 4 like this, right? Or x is less or equal than 4. Another way to do it was if I just want to, let's say, let me write again. I want to leave the x where it was, so minus the 4, right? So we're going to be minus 4 greater or equal than minus, whatever, minus x, right? So now, because when you need to get rid of the negative, let's say divide by negative 1 because it sounds like fun, right? So when you do that, the x becomes positive, but now when you flip the signs, it's going to flip. Yeah. So do it either way, you get the same thing.
Just for fun.
For fun, let's see what else here. Another domain. Why do you have 2 domains? I guess extra problem. Find domain, find domain. Simplify. Oh. Okay. So why? What is that? What's the answer for 2? That's what I wanted to do. It's just 9. I don't know. It just because this has nothing to do with the imaginary number. It's just minus 3 to the 4th, which is it's just the minus disappears because of the 4, right? So it's going to be square root of 3 to the 4th technically, which is just 2 groups of 3. So it comes out of 3 times 3 or 9. Because this is even, you see this thing and this, and because this is, it doesn't matter that it's negative. You can write the square root of 25 right here. And just it's 5. The other one, you could have written it as 4 to whatever is 9 times. Oh yeah, it's going to be 9 times 9, which is 81. It should have been square root of 81 right here. Because this is what 3 to the power of 4 is. Which is 9. Maybe this was the easy way to do it. Okay. So that's it. Practice all these problems. Let's stop recording. And the test is on Wednesday. You don't need to come. You can do it at home.